Hello, I am Kamal Bhatia, Assistant Professor, ABES Engineering College, Ghaziabad. This is the lecture series for the subject Network Analysis and Synthesis, and we are covering unit number 1, Fundamentals of Network Analysis. Today, we are going to discuss the topic Source Transformation Approach. Till now, in the unit number 1, we discussed what is nodal analysis approach and how current and voltage can be identified using nodal and the mesh analysis. Also, we discussed duality. Now, today we are going to discuss the topic source transformation approach. So, what are the different type of sources? Source transformation refers to the technique to convert a practical voltage source to the equivalent practical current source. So now the question is, what is practical voltage source? Everyone needs to understand what is practical voltage source. So this is the circuit diagram for practical voltage source having voltage V and the resistance R in series. So this diagram represents the practical voltage source, and this diagram can be converted to the practical current source. Let's talk about the practical current source. So practical current source consists of current source and the resistance in parallel with that current source. So you can check the practical current source diagram is in the parallel mode, and the voltage, practical voltage source diagram is in the series connected mode. So you need to remember these two circuits. The first one was the practical, this is practical voltage source, and this is practical current source. Now, how can we solve any question? There are some procedure. The first point is develop the fully series circuit or fully parallel circuit to simplify a given circuit. Now, second point is keep that branch as it is, means you do not need to change that particular branch of circuit in which you need to find the current or voltage. Identify, third point is identify the practical voltage source. We discussed just now what is practical voltage source and the practical current source in the given circuit or question, and convert as per the observation. You need to convert your given circuit into fully series and the fully parallel. So let's take a question. Find the equivalent current source. In this question, we need to find the equivalent current source and the voltage source is given. So we can easily determine that this given network is practical voltage source because a voltage source is there along with the resistance in the series. So how this circuit can be converted into the equivalent current source? So all we know that the practical current source diagram is having current source in parallel with the resistance R, and you need to take care of this terminal also. So let's look at the question, the terminal X and Y. Keep that terminal X and Y as it is. What is the value of resistance? Resistance R is equals to 25. So while converting practical voltage source to practical current source, you need to keep the resistance same. R is equals to 25 ohm as same as this one. Now, what will be the value of the current source? So let's talk about that value. This value is quite important. I is equal to V by R. As per the Ohm's law, we can write mathematically I is equals to V by R. So what is V? 100 volt, and R is, what is V? Actually, V is given 100 volt and R is 25. So we can easily determine I is equal to 100 divided by 25. That means current is equals to 4 ampere. So we can write the value of this particular current source, 4 ampere, and the resistance R is equals to 25 ohm. So as per our question, we converted the practical voltage source into practical current source. I'm writing here, this is practical voltage source. Practical voltage source is in the series connection. You can easily observe, and we calculated the value of current, and also we sketched the practical current source circuit diagram as per the question demand. So now, taking the second question, find the equivalent voltage source. Now we need to find out the equivalent voltage source, and the current source is given. So first of all, check this circuit diagram or network and write down what is this. This is practical current source. What is this? Practical current source. And we need to convert this practical current source into the practical voltage source. So I'm writing here what we want. We want the practical voltage source. We want the practical voltage source. So how to draw the diagram for the practical voltage source? Let's draw the plus minus voltage source value. And the value of node voltage source in series with the resistance R. Mark the X and the Y node as it is. This was a node X. This was a node Y. Keeping X and Y as it is. And the value of resistance R will be the same. R is equal to 4 ohm. I'm writing here R is equals to 4 ohm. So very simple. And now we need to find the value of voltage. What is the basic mathematical formula for Ohm's law? V is equal to IR. So now we can write it as V is equals to, what was the I? The value of I in the given circuit was 8. And what was the value of R? It was the 4 ohm. So 8 into 4, it's 32 volt. We can write here the value of voltage source is 32 volt, and there is a resistance R is equal to 4 ohm in the series. So as per our question demand, we sketch the practical voltage source as shown in the figure. So now there is another type of question. Exactly, we need to solve these type of question. Find the voltage V naught. So let's check where is the V naught. This is V naught voltage in the given circuit diagram using the source transformation approach. It's mentioned in the question that we need to find the voltage V naught with the help of source transformation approach. This question can be solved using nodal analysis, mesh analysis, and also now it's written over there. We need to find V naught using source transformation only. So let's check the procedure. We need to convert our circuit into fully series. You need to remember the concept, either fully series or fully parallel. Either fully series or fully parallel, and keep the branch as it is, where we need to find the current or voltage, and identify the practical voltage source or current source and convert it. So let's check in the question. So first of all, we need to keep this branch, V0 branch, as it is. You do not need to disturb this branch 100 ohm, because we need to find the voltage across 100 ohm. So there is no need to change this branch. Now identify the practical voltage source or practical current source. Identify practical current source or practical voltage source so that we can convert into fully parallel or fully series circuit. So I got here some hint that this circuit is, with the help of shaded diagram, this circuit is, or this part is, I will say this part is the practical voltage source. Can I write practical voltage source? It's correct. 250 volt and 25 ohm are in series. So we can easily take the hint from this 250 volt and 25 ohm in series. This is the practical voltage source. We can convert this practical voltage source into the practical current source. Practical current source. Right? When we convert this into the practical current source, so all the branches will be in the parallel. So let's look what we need to convert. The arrow will be the upward direction because it is plus minus. We need to take care also. Now I am marking the resistance. The rest part of the circuit will remain same. Check the rest part. The rest part is 8 ampere. The rest part is 8 ampere. This is 8 ampere. What is next? 100 ohm. Keep 100 ohm as it is and write it as plus minus V naught as given in the original circuit diagram or the question. What is this? 20 ohm. So I need to write first of all this current I, as we did in the last two questions, how to find the practical or how to convert both the voltage source or current source into each other and the vice versa. This resistance value will be the same 25 ohm. We know the concept. And this current value will be the 250 volt divided by 25 ohm. 25 ohm. So now I am writing here the value of current source will be the 10 ampere. Now you can check all the elements are in parallel. You can easily check all the elements are in parallel. So our target using the source transformation approach. What was the target using source transformation approach? We want the given circuit should be converted into fully parallel or fully series so that we can apply current divider or voltage divider in an easy way and can find out the voltage or current in any part of the circuit. So this is all parallel. I'm writing here, this is all parallel circuit now. You do not need to change this branch. V0 100 ohm branch, you do not need to change this 100 ohm branch. Now check the resistance in parallel. 25 and 20 ohm is in the parallel. I'm writing here 25 ohm and 20 ohm resistance will be in the parallel. I need to draw one more circuit to simplify this. So I am writing here 25 and 20 ohm in parallel, and the current source 10 ampere and the 8 ampere are in opposite direction. So taking this, so how can we, and the value of 25 and the 20 ohm, 25 and the 20 ohm parallel resistance value will be the, I can write it here as 20 ohm. So now let's find out the value. Or these, 11.11. I need to correct this value will be the 11.11. 11.11. So I need to sketch the second step of this circuit. As the second step of this circuit, current source of 2 ampere and the resistance of 11.11 ohm and the resistance of 100 ohm. This is plus minus V0. So now this is simple circuit and we can apply the current divider rule. First of all, I'm writing how we would like to approach V0. We need to find out the V0. V0 will be the I into R, and the R resistance is 100 ohm. So we need to find the current across the 100 ohm. In this branch, what will be the current? So I am applying here current divider rule. Apply current divider rule. We all know that what is current divider rule. When the circuit are in the parallel, all the branches are in the parallel along with the current source. So we can apply the current divider rule. What is the concept of current divider rule? We need to find the current across the 100 ohm. So writing 11.11 opposite resistance 11.11 into 100 multiply by the total current, that means 2 ampere. So now the value of current is, on getting this, 0.19 ampere. I got the value current across 100 ohm. I'm writing here also current across 100 ohm is 0.19 ampere. Now we can put this value into the equation number 1. Put in equation number 1, and V naught will be the 0.19 into 100. Approximately 19 volt or 19 point something. We find out 19 point something. This will be the answer using the source transformation approach. So we discuss here how we can solve any circuit with the help of source transformation approach. The basic funda, we need to know the procedure. We need to convert our circuit into fully series or fully parallel. This is first concept. Keep the branch as it is, where we need to find the voltage or current and identify the practical voltage source. Just like we did, we find the practical voltage source in this circuit and convert it into all parallel or all series as per your observation. You do not need to change this value or change this branch where we need to find out the voltage or current. So this is the basic concept in the source transformation approach. So we taken references from the different books. Van Valkenburg, Network Analysis, Pearson 2019. A. Anand Kumar, Network Analysis and the Synthesis, PHI publication. Thank you for listening this lecture.